students. Today we will study chapter 10 Light of class 10th. So in this chapter or in this video actually we will study about these topics, that is light, reflection of light, laws of reflection of light, spherical mirrors and rules for drawing the ray diagrams. So let's start with light. So what is light? So you would have seen means whenever you are there in a dark room, are you able to see anything? No, we are not able to see anything. But whenever there is light on in the room or sunlight is entering inside the room, we can see the things. So in physics, what we say, what is light? So light it is a form of energy which gives sensation of sight. So light is a form of energy, and due to light we are able to see things. Now why we are able to see the things when there is light? So next thing is reflection of light. So we see things due to reflection of light. Now how does this happen? See, we all know that sunlight or white light, it consists of 7 colors. So whenever light falls on any object, so what happens? So when light falls on any object, it reflects. So all objects, they reflect light. The intensity of the reflected light depend upon the substance on which the light is falling. Suppose a white light is falling on a green object. So what will happen? So white light consists of 7 colors. 7 colors, that is vibrant, so V stands for violet, I stands for indigo, B stands for blue, G stands for green, Y stands for yellow, O stands for orange, and R stands for red. So white light, it consists of 7 colors. So what happens? When this white light falls on any object, I have said that when white light falls on a green object. So white light falling on green object. So what will happen? The green object will absorb all the light falling on it and it will reflect green color. And this reflected green light reaches our eyes and we are able to see that object as green. Similar thing happens when it falls on any other color, just like suppose an object is yellow in color. So we see that object as yellow. Why? Because white light is composed of these 7 colors and the yellow light is reflected and rest of the light rays or the rest of the wavelengths are absorbed by that object. So we see objects due to reflection of light. When light falls on any object, that object reflects light and that reflected light reaches our eyes and we are able to see the things. So reflection of light means bouncing back of light when it falls on any smooth, polished surface. So what is reflection of light? Bouncing back of light when it falls on any smooth and polished surface. Now what is smooth and polished surface? See, all objects reflect light, but I said that intensity of light ray reflected by that object depends upon of what texture that object is made up of. Just like you would have seen that when light falls on any mirror, so what happens? We are able to see the clear image. We are able to see the clear image of that object. But when light falls on any opaque object, just like this board, we are only able to see white color or the color of the ink. We are not able to see our image on this board. But a mirror is capable of reflecting near about 99% of light rays falling on it. What? A mirror is capable of reflecting 99% of the light rays falling on it. Rest of about 1% is absorbed by the surface. So, reflection of light, I will repeat, it is bouncing back of light when it falls on any smooth polished surface just like mirror. Next is reflection by a plane mirror. So, suppose this is a plane mirror. So, M dash is a plane mirror. So, now consider that a light ray is incident on it. This is incident light ray. So, when light ray strikes the mirror, so at this point, what will happen? At this point, the light ray is bounced back. Just like when we throw a ball on the wall, what happens? The ball bounces back to us. In the similar way, the light, when it falls on smooth and polished surface, like plane mirror, so what happens? It bounces back. So this ray which is bouncing back is called the reflected ray. Now here the point of incident, at this point of incidence, if we draw a norm, if we draw an imaginary ray perpendicular to the surface, this imaginary ray is called the normal. So this is how the reflection by a plane mirror occurs. Here in this diagram, M dash is plane mirror, N dash is the normal to the surface, normal to the surface. This you all know, this is incident ray and this is the reflected ray. Next is characteristics of the image formed by a plane mirror. So, plane mirror, you would have seen the normal mirror that we use in the dressing table. That's a plane mirror. So, what is the size of image of yours that you see on the plane mirror? The size is same. So, first characteristic is the image formed is of same size as the object. Now, the size of the image is just a photocopy of yours image, so the size is same. Next is the distance of object from the mirror. So the distance of object from mirror and the distance of object, the distance of image from the mirror is same. So the image is formed at the same distance as the distance of object from mirror. These are two properties. Next is property is lateral inversion. So what is lateral inversion? So any image which is formed on the plane mirror is laterally inverted. This means the right looks at the left and the left looks at the right. So lateral inversion is a property. Suppose there is one alphabet L and we have a plane mirror in front of it. So this is how the alphabet will look like. Image of object is laterally inverted. That is why the word ambulance is written laterally inverted, so that when its image is seen from the rear view mirror of any vehicle, the word looks it should look correct. Spelling should look correct. Next property is image formed by plane mirror is a virtual image. virtual image. So what is a virtual image? Virtual image is that image which cannot be formed on screen, and the real images, they can be formed on screen. So virtual, how does a virtual image is formed? Virtual image is formed when the light rays don't actually meet after reflection, but a real image, it is formed due to actual intersection of light rays after reflection from the mirror. So a plane mirror forms a virtual image. Next we will study about laws of reflection of light. So what are laws? There are laws for reflection. First law is angle of incidence with is equal to angle of reflection. So angle of incidence with the normal is equal to angle of reflection that is made with the normal. Okay, now let us see. This is a plane mirror, M dash. This is the incident ray. I denote it as I. N dash is the normal. This is the reflected ray R. So what is angle of incidence? Angle of incidence is the incident ray which makes angle which the incident ray makes with the normal. This is angle of incidence, and this one is angle of reflection. So first law says that angle I is equals to angle R. This is first law. Second law is the incident ray, the reflected ray and the normal to the surface, they all lie on the same plane. Same plane means suppose this is the surface. So on this surface, or suppose this is the reflected ray coming from this side. So sorry, this is the incident ray coming from this side. Here there is one mirror. So what will happen? The incident ray, reflected ray and the normal to the surface, they all lie on the same plane. This is the second law. The second law can be written as incident ray, reflected ray and the normal to the reflecting surface all lie on the same plane. So laws of reflection of light, they are very important from the examination point of view. Next is the types of mirror. Types of mirror that we will study in this chapter. So there are two types of mirror. One is concave mirror another is convex mirror. So children, what is a concave mirror? Concave mirror there is one curved surface like this. This is polished surface. And this is the reflecting surface. So this type of mirror where there is a cave-like structure, where there is a cave-like structure like this. So this is a concave mirror. So this is a concave mirror. So this is the reflecting surface. So reflecting surface is curved like this. This is curved inwards. So this is a concave mirror. Now if the reflecting surface is curved outward, this is the polished surface. And this is the reflecting surface. So here you can see that this is the polished surface and this is the reflecting surface. So this type of mirror is called the convex mirror. So curved inwards is a concave mirror, curved outwards is the convex mirror. Before we further move on to the spherical mirrors, we must first discuss about certain terms related to the spherical mirrors. This concave mirror and convex mirror, these are also called spherical mirrors. Terms related to spherical mirrors. Now a spherical mirror, whether it is a concave mirror or a convex mirror. Suppose this is a concave mirror. And this is a convex mirror. So this can be assumed to be a part of a spherical ball. So this concave mirror can be assumed to be a part of hollow spherical ball, in which this inward surface is the reflecting surface. Similarly, a convex mirror can also be assumed to be a part of a spherical hollow sphere, and the outward part of that hollow sphere is the reflecting surface, and this is the polished surface. This is the polished surface of concave, and this is the polished surface of convex mirror. So here you can see that we are assuming the concave mirror or the convex mirror to be a part of a hollow sphere. So this hollow sphere would have one center. This is also center of this hollow sphere. So this center is called center of curvature. It is denoted by C. Center of curvature is denoted by C. Similarly, here also, this is a hollow sphere. This is the center of hollow sphere. So, this is called center of curvature. Center of curvature is the center of an imaginary sphere of which the concave mirror or the convex mirror is a part. Center of curvature is a center of imaginary sphere of which a concave mirror or a convex mirror is a part. Next is now term is, this is center of curvature, this is also center of curvature. Now if I suppose an imaginary line passing through center of curvature, this imaginary line is passing through center of curvature and dividing this concave mirror into two parts. So this point where this imaginary line is dividing this concave mirror into two parts is called the pole. So pole is a point on the spherical mirror which lies on its geometrical center. So pole is a point on the spherical mirror. Spherical mirror is just like a shape of a saucer or a plate shaped, and the center of that saucer or the plate is just like the pole of the mirror. So a line which passes through center of curvature and it divides the mirror into two parts. When we are viewing the mirror from this side, it is dividing it into two parts. So this and this point of intersection of this imaginary line and the spherical mirror, it is called the pole. Similarly here, this is the imaginary line passing through center of curvature and this P is lying on the geometrical center. Next is the distance between center of curvature and the pole. Distance between the center of curvature and the pole. It is called radius of curvature. What is radius of curvature? It is distance between center of curvature and pole. It is called radius of curvature. Pole is denoted by P. Radius of curvature is denoted by R. So this distance between pole and center of curvature, it is radius of curvature. Next term is aperture. Aperture of the mirror. So aperture of the mirror is the surface which reflects light. So normally for a spherical surface, it is when you see the 2D image, so the aperture is like this. So this is for a mirror, a concave mirror or a convex mirror. So this area which reflects light it is called the aperture of the mirror, right? Next is the focus. What is focus of the mirror? Focus is denoted by F. Now what happens? Suppose this is a concave mirror, this is pole and this is center of curvature. Now when light rays, parallel light rays falls on this mirror. So when parallel light rays fall on this mirror, so what will happen? The light rays, they will reflect, they will follow the laws of reflection of light. So this type of mirror, that is concave mirror, is also called the converging mirror. Concave mirror or converging mirror. So it converges. It converges means it makes the light rays intersect to each other. So this is the incident ray. So after reflection from the mirror, it will converge. This is the reflected ray. Again, this is another incident ray. So what will happen? It will converge. If we take more rays, what will happen? Those rays will also converge. So where the point where maximum light rays they converge or they meet after reflection, this point is called focus. So when parallel beam of light it reaches a concave mirror or a converging mirror, after reflection from the mirror it converges to a point. So maximum light rays they converge to a point and that point is called the focus. It is denoted by F. Now the distance between focus and pole, the distance between focus and pole is called focal length. What is focal length? It is distance between focus and pole of a mirror. It is denoted by small f. Focal length is denoted by small f. So this distance is the focal length of the mirror, right? Next we can see for a convex mirror also. For a convex mirror, suppose this is a convex mirror. This is the imaginary line. This is pole of the mirror. This is center of curvature C of the mirror. Now suppose the parallel light rays are approaching. This is one incident ray. This is another incident ray. This is one more. So these are incident rays. What will happen? When they will strike the mirror, they will reflect. But here in this case, this convex mirror will not converge the light rays. It will diverge. So that is why it is also called diverging mirror. So what will happen? It will diverge the light rays like this. This is incident ray and this is the reflected ray. This is another incident ray. It is the reflected ray. This is reflected ray. This is reflected ray. So you can see the reflected rays are diverged. So if you extend these lines beyond the mirror or behind the mirror, so here you can see that these light rays, the reflected light rays, appears to come from a point. Now this point is called the focus. These light rays appears to come from this focus. So this is focus of a convex mirror. Again, the distance between pole and focus of the mirror is called the focal length. are the terms that are related to spherical mirrors. Let us revise. First is pole. What is pole? Pole is the geometrical center of mirror. Center of curvature. It is center of imaginary sphere of which mirror is a part. Then radius of curvature. What is radius of curvature? Distance between pole and center of curvature. Then we have learned about focus. Focus, it is a point where parallel light rays falling on the mirror after reflection meets or appear to meet or appears to meet. So these are the things that we have studied. That is the terms related to the spherical mirrors. One more is focus, sorry, focal length. So focal length is distance between pole and focus of the mirror is called focal length. Next we will study about the rules for the formation of image. So whenever we draw the ray diagrams, there are certain rules associated with concave mirrors as well as the convex mirror for the image formation. So first rule is, these are very important rules and they will help you out to draw the ray diagrams. So watch it very carefully. Rays coming parallel to the principal axis after reflection from mirror passes through focus. So any ray which is approaching the mirror and they are parallel to the mirror, or they are parallel to the principal axis, so after reflection from the mirror it passes through focus. Let us see. So this is a concave mirror, this is pole, this is principal axis, this is center of curvature, this is focus. Okay, now a ray parallel to principal axis falling on the mirror after reflection passes through focus. So this is the case for concave mirror. Now for the convex mirror, let us see how you can draw this ray. For a convex mirror, this is the polished surface, this is principal axis, focus, center of curvature. Now this side is the reflecting surface. So a ray of light parallel to principal axis, after reflection it passes through focus. Now here this convex mirror is a diverging mirror. So it diverges the ray of light falling on it. So what happens? It diverges. So this is the reflected ray. This one is the reflected ray. When you will produce this ray, you can see that it appears as if it is coming from focus. So this is the first rule for the formation of image for the spherical mirrors. Now second rule is, which passes through focus after reflection from mirror goes parallel to principal axis. So this rule is inverse rule of the rule 1. In rule 1 we have seen that when a ray of light which is coming parallel to principal axis, after reflection from the mirror it passes through focus. So the incident ray is parallel. Now in this case we will see that we will take a ray which passes through focus, and after reflection it will pass parallel to the principal axis. Let us see first for the concave mirror. This is a concave mirror. Principal axis, focus, this is center of curvature. Now I am taking this ray, incident ray passing through focus. This is incident ray passing through focus. So what will happen after reflection? After reflection this ray will go parallel to principal axis. So this one is the reflected ray. Okay. So this is for the concave mirror. Now let us see how we will draw this ray for a convex mirror. So this is a convex mirror. This is principal axis. This is focus, and this is center of curvature. Now we will assume one ray an incident ray which is passing through focus. So this is incident ray, and when you will produce this ray you can see it is passing through focus. It is not actually passing through focus, but this is oblique in such a way that it is directed towards the focus. So after reflection what will happen? After reflection it will go parallel to principal axis. This is how you will have to draw the ray which is incident towards the focus, and after reflection from a convex mirror it will go parallel to principal axis. This is a convex mirror. Next rule is when a ray of light is incident at pole of mirror, so let us see. So this is a concave mirror. focus and this is center of curvature. Now a ray is coming towards pole. This is the incident ray. This is the incident ray towards the pole. So here the principal axis, this principal axis will act as normal and this is angle of incidence. So here the reflected ray will go like this. So here angle I will be equal to angle R. So this is how you will draw for the pole. When incident ray is directed towards pole, this principal axis will act as normal to the mirror and here angle I will be equal to angle R. Next is this is for concave mirror. This is for concave mirror. Let us see for the convex mirror also. This is a convex mirror. This is pole. This is focus. This is center of curvature. Now, this ray is incident towards pole. This is the incident ray. This is the reflected ray. Here also angle I is equal to angle R. This is for convex mirror. Okay. Next rule is when a ray of light is incident towards center of curvature. When a ray of light is incident towards center of curvature. So this is a concave mirror. This is pole, focus, and this is center of curvature. So we have to take a ray, incident ray, which passes through center of curvature. So this ray retraces its path. This ray retraces its path. So the incident ray overlaps with the reflected ray, or you can say the reflected ray retraces the path of the incident ray. So this is incident ray and from here it retraces the path. There is no angle between the incident ray and the reflected ray in this case. Let us see for, this is for concave mirror. Let us see for convex mirror. So this is a convex mirror, principal axis, focus is the center of curvature. Now I am taking a ray which is incident in such a way that it appears as if it will pass through center of curvature. So this is incident ray. When you will produce this ray, it appears as if it is directed towards center of curvature. So from this convex mirror, this ray will retrace the path. So this will be the reflected ray. So when a ray of light is incident towards center of curvature, it retraces its path. This is for convex mirror. So that's now for today. We'll learn how to draw the ray diagrams in the next video. Thank you.